want to do this video to show you how I'm developing my trade bot with AI. I think we're at this point where we can develop things kind of like Iron Man does with a Jarvis sitting next to him. We don't need to know everything. We just need to be able to create, research, inquire, and then decide, and then it'll put it together. So what I'm doing now, I have a bot that's already done with AI, and it does okay. I haven't seen it become consistently yet, but so far it's on the top two vaults of the exchange. And what I'm doing now is to do a version 2 already. I'm like, dude, that's kind of quick. And normally we'll run it for about 6 months to a year before we do a version 2 while we improve version 1. But I'm at the point where I just, since we could do it so fast that we could just create a version 2, re-optimize the code, clean it up better, and it's just, version 1 is kind of like a spaghetti mess, and I want to make it better. Also add some more functions and tweaks to it, and so I want to walk through what I want to do. The first thing you want to do is kind of create a copilot instruction. It kind of it gives the programmer an instruction on how you want things done. So if you want to, comments to be a certain way, you want to log certain things, you want to have a certain style on how you program, you want nested loops and not nested loops. I put all those things in there on how I want to program in my style. All the little quirks and things that you've developed over time that you want done, that's where the copilot instructions go. So you might want to construct that first. Kind of look at the copilot instructions I have here. Let's kind of look at it. I guess this is the big stuff here. I kind of tell it that, I want it to use certain environments. I want it to use certain configuration files. I want it to log all my artifacts. I want things to be done in dictionaries so that you pass things in dictionaries and you return in dictionaries. I also want things to be prefixed. So the file name starts with trunk morph. All the classes and functions start with trunk morph. So if I see it in my logs, I know exactly where to go, and it's easy for me to find it. But I guess with chat, I guess you could be ambiguous because it can find it for you. But that kind of gives me an idea of where all my functions are coming from that's being called. And so I also log everything so that all my functions that get called, I can see what goes into the function after it's manipulated, and then what gets sent back. And then we can then debug quickly, because you can't debug anything if you can't see it. So we can see a whole history, and it's all nicely indented properly, so that we can see from function to function as it's nested and nested. That way, it can find problems quickly rather than running around in circles trying to poke around with things. Okay, so you want to make sure you get that done, and also have a logger that does what you want it to do. So I will also develop that logger too. Okay, I'll come looking for my SOP. It might be in another folder. I wanted to kind of show you that. It's kind of like the standard operating procedures. Can't really find it, but anyways, that's kind of where I'm at. So now that I have the spaghetti mess, I've created a V2 folder here, and now we're working on the README for the V2 to kind of talk about and discuss what the plan is. So it's kind of starting to create this plan on what I want to do with my bot, how I'm gonna implement and transition things, and what we're gonna name it. And so we're gonna basically base off of version 1, and we're gonna recreate what we just did, but in a way that is more cleaned up. Okay, and yeah, and so I'm kind of discussing here about my using my GPU and whatnot, and kind of just defining things, and so it's kind of using the same rule structure, everything else as my SOP and Copilot rules, and it's just kind of understanding so we're all on the same page before we actually start implementing, start coding. Okay, so hopefully that's kind of helped you guys to do that. Once that start, then I will start to say, hey, go ahead and start kick it off. But yeah, so we're gonna be integrating with Hyperliquid and be able to create that, and so we're gonna support that, and also have different market limits. I think I also want to talk about my environment files. So let's go ahead and do that. So for example, I also want env files files that are strictly for sensitive information. Like API keys. I'll call it private user settings, something like that. .env, and then also initialize env files. Call initialize user settings env, and also hot swappable env files. That way, it can, if anything's changed, it'll call it from these separate files. And then also I'll ask it what it thought about that design. And instead of just saying, hey, I want it this way, maybe it has an opinion about that, whether it might be conflicting or it might be bad. So we'll call it hot swap user settings. What are your thoughts on this? Is it a good design? And then, are there any other env type situations I haven't thought about? Also, should we start storing price data in a database that is reusable? I think we have something that is light that we can later turn into a database. It gets really large. Alright, so we're going to see what it says. That way it kind of gives us an idea, and then we're going to add that to the readme before we program. And anything else, I might spend maybe a couple more days thinking before we actually write any code. A couple of hot showers, maybe a couple of days to ponder and kind of think things through, and then see what it says. Maybe some more research on the side, and kind of just research with it, talk with it, as it kind of helps us build and collectively put this together. And also, what if we want to put this on a server, or maybe turn it as a software as a service? How would that all work? So yeah, starting to store price data on a reusable store is a good move, especially if you want consistent backtest, live replay frames, faster iteration, no redownloading, no reparsing, stable audits, what canvas did in Model C. Pen-only files as source of truth. So we're going to have JSON-L files already aligned with current live logging style, right canvas partition files. DuckDB embedded as a database interface without running a server. DuckDB can query part directly, so you can scale from small to large without migration crisis. Later migrate to real database only if needed. Okay. And then the timestamp. Okay. Time frame, their source. Okay, cool. And I think we kind of ran into so we compile with your consistent data, makes timestamp explicit as milliseconds. So that's something that we have to kind of consider. And then market data, I think we already talked about this one, right? Reuse, consider backtest, live replay. Yeah, we talked about this. Let me see what the first one did. Maybe just cycles, part one. Yeah, I guess it's just cycles. All right, so let's go ahead and keep that. And can we leverage, or should we copy over the price data already have to trade on? Let's see what it says. Or a pin to it. And then see what it says here. I'm going to quickly inspect the store candle data you already have. And I just like to have it all in one project. It's like once you get it going and it gets smart, I kind of feel like I want to write all my projects on the same workspace, and then just create a separate folder for it and just start creating things, and then you don't have to worry about importing things from other places and all this other stuff. Yes, here's what you already have, but don't append forever to the existing training CV. Use the existing training as the baseline seed, import it once into whatever you have. You already have. It's mutable for reproducibility. If you have a pen rosa, you eventually get provenance, dedupe headaches, duplicates. Append new income data into a separate canonical store, and optionally regenerate training data sets from that store. You already can accumulate candles. What I can recommend actually raw layer keep writing JSON append only, never edit it. Canonical training, build data sets from canonical and record artifacts. Okay. Tiny import compactor. Next, import canonical partition. Okay. Yeah. Let's add it to the plan, but don't code anything in it yet. I have live runner live web socket from Apex, but I think I want to do the same with Hyperliquid. We just merge them. To get things with data. Alright, so we'll see what happens, because I kind of still want to rebuild it with Hyperliquid WebSocket data. See what it says. I'm going to update the V2 planning slate or cover multi-exchange catalog ingestion. Now, mixing raw streams so you can start building an ununified data set safely. Data subset multi-exchange account ingestion Apex for Hyperliquid. That answers your questions directly. Yes, we can merge them to get started data, but we should merge at the canonical layer. Not by mixing raw WebSocket files. Concrete file layout suggestions raw append only. Oh yeah, so we don't want the raw files because they are different. So we gotta merge and kind of like pick out what we need from each other. That way we would have some duplicates and whatnot, and also the format stays proper. About trading view, and we just grab I don't know, data from them, or is it better for to get real real precise entry and exit prices, or take of live data and not summarize or average price. But for live execution price, I use both, but with a clear rule: any model that will trade on Hyperliquid must be validated and eventually trained on Hyperliquid source data. In trading view for general, when you long history, you can get it quickly. Let's see what it says here. Cross exchange, generic BTC, macro, medium, horizontal features, where tiny microstructures differ much less. So using hyperglyph data, you can care about precise field behavior, spread volatility by construction that affects your DCA, spacing and trailing type. Fee funding regime, correct price definition. Some feeds last trade, some are marked prices, some are indexed. Your strategy must match what you act on. Realistic backtest, trading view, wick behavior, timestamp. So key point, the training view gives 1 minute candles. It's still a summary. For execute quality submission, you need at least exchange the native 1 minute candles aligned to their timestamps, ideally micro signals. Yeah, that's kind of true. So phase 1, bootstrap, use trading view history to reach pre-train macro meaning components, tiny check, poly loops, domain replay evaluation, hyperloop candles and if possible, trade principal challenge. Phase 3, live, keep appending hyperloop raw data periodically, replay optimize. Yep. So yeah, I do like phase 1, phase 2, the main lock is switching training, replay evaluations, hyperloop candles and if possible, trade. Yep. Okay. Okay, yeah, sounds good. Yeah, sounds good. Let's add to the plan, and if it trades on a different exchange, it does the same. Alright, so yeah, so we're gonna do that plan, and times normalize. Alright, so then we're gonna talk about the inputs like to neuron. What would be inputs to the neuron that would matter most? Current position, liquidation, distance, liquidation settings, average entry price, position size, unrealized P&L, wallet balance, direction, take profit, stop loss, profit, orders placed, open or open, closed, filled. What else? Funding fees, order book, and what outputs can we use to route also. Each exchange can understand and feed what it needs. Can we also feedback loop its mistakes or profits? Okay, there you go. Let's try that. Alright, so now we're gonna kind of develop the neuron a little bit. So we're gonna have some inputs. Or we're gonna send order book information into it, or we're gonna send its position, where it's at, so it knows it's longing or shorting. What's its status, what the count position, what it can do, can it leverage? Oh yeah, I also want to make sure that I want to allow it to change its leverage too. So. Let's see here. Most ranked by always available. Nice to have. Always available core state should exist in every exchange. This minimum side long, short, flat. Position side, notional leverage, average entry price. Unrealized P&L or yep. Wallet balance, available margin, risk limits, max notion per trade, current exposure, market last price, pick canonical decision price. Alright, level 2, execution risk, liquidation price, the distance to liquidation as fraction. Funding rates, accrued funding, open orders, slippage, microstructure, order book top levels, bid ask, the balance trades, buy and sell volume, Q position, latency, reject, okay. Make it portable, normal to single exchange state dictionary. Don't feed raw exchange payloads into policy. Instead, Adapter produces normalized dictionary with stable keys even if some are none. It consumes only normalized keys. Features include capability mask, so the model learns what's real versus missing. Okay, so we examine confidence in that code. Order summaries nears okay, decision prices, Boolean support. So it's gonna be hold, enter, add, reduce, exit, flip. Side long, short, or derived. Behold. Where'd you see? I kind of want to change this hold here because it could be hold, no position, or hold, current position. Enable disable distance price, take profit intent, reduce only time in force. Alright. Uh-huh. Excuse me. Good so far. Want it to decide the order quantity, decide the leverage, set, also the action type. I feel that hold is unclear for holding a position that it's in a position or holding what when it's not in a position. So when I see the logs, can we just say stay out of position? Or a shorter synonym to it. Add, reduce, exit, flip. So currently reduce and flip spams, but hopefully it doesn't do that with better training. Alright, let's see what it says. All right, so we're kind of learning here, kind of building the plan. So you kind of see how just we're gonna spend some time sharpening the axe before we actually make the first cut. And we haven't written any code yet. Okay. Now we gotta just kind of build it piece by piece, and then kind of confirm, do a smoke test, make sure things will work. They call it smoke test, but I think it's more of like testing your code, make sure it's showing that you have a desired outcome. But a lot of times when it does run into problems, it's because you did not print what went into the function and what went out of it. So that's key. Remember that. Make sure you log all that so that you can see what goes in, what goes out. That way it can see what goes in, what goes out, and can solve the bugs quickly. When in position, hold position. So hold POS and stay out. Okay, so that's good. Short send them out. Okay. And log policy action every cycle, so it wants X but gates did Y. Oh, this is always clear. Policy decides quantity. Added B2 policy schema target exposure. Adapter responsible for adding converting to exchange, and reduce flip spam. Okay. Okay. Okay, great. Can we wait? Can we have a sequence? For example, it will fire or trigger intent to add, flip, reduce when we're not in a position. So to only allow those when we're actually in a position. Stay out, enter with direction. Yeah, I like that. Nice. Amazing. Alright, so that's clear. We got this down. So proposed valid actions, current state, add while flat. B2 must emit a gate denial with a stale reason. Action requires position. Record the training diagnosis. Yep, stay out when flat. This makes sequence behavior explicit. Flat model can only choose stay out or enter. Once entered, model can manage via add, reduce, exit, flip. Okay, great. Huh? Okay. Okay, cool. Alright, cool. So let's go and keep that. Thinking into the future, decide to make this a SaaS software with Anvil that works Python integration. What do we need to consider ahead of time? Or should we just run it on a vault where it copy trades and only charges a 10% fee when profitable? Alright, so multi-tenant ICE co-installation. Every user needs their own bot instance. Never share processes stay across users unless you have strict namespacing secrets. Compliance, you'll need a real secret store Saying any approach is great locally, but not enough for SaaS. Yeah. You want the trading brain to be callable in step state decisions, so you want to run a worker to service. The in-out core job worker mode. SaaS needs to be background workers per user. Scheduler, health checks, restarts, ammo can be the UI control plane, but trading loops should be run in worker environment. You control the VM container. All that you need immutable event log per user. Rate limit exchanges. But don't run latency sensitive perks. Yeah. All copy trading 10% fee, much simpler. You can trust audit users. This is SaaS eternally, stateless core, but deploy first as a single tenant service in your own vault. That, yes. Root it out low grade. Keep the v2 core prediction out. Keep all event logs. Treat user config as layered inputs. And then treat runtime state versus stable reason codes for every, okay. Which direction you're learning. SaaS multi single vault copy trading. Future SaaS readiness. Yeah, let's add your SaaS readiness as far as user private use settings. So if we need better than .env files, let's do that. But mostly I will stay with copy training since I'm up to SaaS also requires more GPUs and hardware, right? Alrighty, let's see what it says. So we're gonna not use .env files. Splits a good local developer, but SaaS requires stronger solutions, strong source secrets, and a secrets manager. HashiCorp Vault, Azure Key Vault, AWS Secrets Manager. Okay, I like that. I think we can probably use that. Never log secrets, only present missing. See the key difference. Plan ahead. Secrets, inject adapter. Okay. I think Anvil has a secrets thing that we can use. Yep. I think Anvil has a database for users that can encode the credentials. You can pull it in. API for now. Alright, so plus that focus on secrets, plus a short note on what actually drives GPU hardware scaling, multi-tenant training versus lightweight live inference. Okay. Keys, trigger action, SaaS solution, Anvil. You should be control plane to trading runs and worker processes. Hardware scaling out here, you're basically right. SaaS all needs more GPUs, but mostly because of per user training, replay population compute. Live inference alone is usually cheap. It's everyone gets their own training loop that blows up GPU needs. Oh, okay. So the training is what blows it up. Okay, copy training keeps scaling simpler. Training involves small number of strategies. Many followers share the same single streams. You want a short copy training, a fee accounting note, high watermark. Realize that people different. So the future terms for fee is unambiguous. Okay. The copy. Exchange just calculates for us when new investors join our vault and deposit into our trading vault. Store, as long as you treat it like a real secrets manager, store credentials encrypted at rest, not just encoded, and only decrypt server side. Never send raw secrets to the browser client. Only pull them from your bot worker in a authenticated API call. Key rotation plan, present missing logging only and strict access control, admin only reads per user scope. On copy training fee accounting, even if the exchange calculates it for you, it still helps to understand what it's doing in your analytics, reporting, investor and creating, matching reality. Most copy system implement performance fee, your 10% using some variant of profit share, 10% profits. Investors only pay fees on new profits above their prior peak. Crystallization events when fees are actually charged, often withdrawals per investor deposit receive shares in the vault and credit share. Vault trade shared price. Yeah. When profit exceeds the investor, you author monitor. So what you need to track, even if exchange charges it. To avoid surprise, you want to log and monitor fee rate configured on the vault. 10% performance fee, that versus growth credit fee after trading. New investors should not pay for profits earned before they join. Price solves this if applied correctly when fees crystallize. You should confirm, is it performance fee based or realized P&L? Yeah, we'll use for liquid, but I don't think we care at this moment. I don't see that it affects our trading decisions in the network. Within the network, just see additional or updated wallet when new investors join, so it can use it. Yes, the wallet's deployable trading account balance free cloud actually increases investment, and you feed the wallet balance free policy with the network, and you'll see the chain only. Two important gotchas so it doesn't mislearn. Balance jumps. It looks like P&L unless you label them. A deposit and exchange jump, not trading profit. If the model only sees balance up, it might reinforce actions right before the deposit. The fix is also fed release log for training. A simple event feature like internal balance delta. Credit assignments mistakes. Risk scaling should be explicit. If you size orders for target exposure, free collateral leverage, then deposits you actually increases position sizes. That usually is what you want, but you want to gates like max notional, max leverage, min quality. keep it safe. So you don't need vault accounting input, but you do want account state inputs, wallet free, collateral, margin used, and ideally still have withdrawal events from true P&L for training. If you want, I can add those deposit withdrawal flag note. Okay, yeah, let's add withdraw flags. I do also want to allocate 10 process generate on a weekly basis to move to a funding account instead of the perpetual account to protect or keep funds safe from it was called cross margin that could clear the entire balance effect. Okay. Alright, let's continue. We've been developing this for about how long now? I don't have a timer here. Well, oh, there it is, 42 minutes. Wow. Well, you're still with me. Thanks for sticking with me, and hopefully you can start creating your bot too. I didn't do this in the beginning when I first started version 1, which is why it's all spaghetti mess. But now I kind of learned to do this, and the big thing is the copilot instructions. That's huge, because then it was able to program the way I want it, because it was programming its way, creating its own variables. I'm like, what are these variables? I can't even understand the code it's creating, you know. And then it wasn't testing it, and it find bugs, and I was like, they couldn't find the bugs. So, well, they print the logs. So I'm like, dude. So they started printing those logs, and they started getting it. All right, so we added deposit draw flags, login crimes, balance, frequent jumps, training replay, P&L, not raw balances, deltas, deposit withdrawals, siphon the safe funding account to reduce cross margin white risk. Only siphon realized net profits, never siphon if it harms. Siphons treated, still training. If you want to lock one detail for now, the plan should be to siphon only happen when flat safe is, or allow it when in position as long as fee collateral stays above threshold. Siphon when flat. There you go. Alright, so I think I am done. I'm going to take a break now. And then I'm going to ponder and think if I need to add any more to this plan. And then maybe just start programming the first few neurons and go from there. Okay. See Alright. Okay, let's re-summarize. How deep and how big is our trainer network to be, and are we using micro tensors to model each neuron as a wave equation. Makes sense to connect it to multiple neurons. Wave equations. Does it make sense for it to randomly pick from AX plus B, wave equation, Laplace Fourier series, Laplace, and add all the connections together. We'll see what happens. This is a crazy one. This is all my experimental. Does it make sense? Maybe it's just a big mess kind of thing. Replay fitness improves, you're not bottlenecked. Are we using microtensor per neuron? Depth wave question? Yes, that's intended. Small parameter bundle frequency or snapping plays up to real imaginary, so this update behaves like a depth. Okay, multi-wave neurons, yes, coupling. Just keep the connect to batchable, mass tensor, route table, definitely going so pick between the AX plus the depth wave. Something not as a per edge anything goes random choice, but it gets hard to train debug. Search space consistent users. A better version is always include a linear skip base path, helps train. Okay, use on primary dynamic unit. First depth wave and prove value. Multiple base types, do it as a small mixture of experts that learn mutate type gate at new module level. Not arbitrary connection around this. If you want to lock a concrete default today, profile the linear skip plus optional type gate seconds piece later. Okay, that's it. Okay, let's in. So L2 is depth of 46 layers. D. And what is D? And how many outputs? Can we add new inputs mid-training or new puts to the neuron work if we want more parameters fed in or logics out. Alright, let's see what it says. It's like, yeah, this crazy guy got crazy ideas. See if we can make this work. Model with hidden state embedding dimensions per layer. Larger D means capacity per time step. Higher compute memory, truck layers. Depth is the main number. Okay. All right. What it says. Locked in model size D, model width and size per layer. Chunk depth locked default L2. So is L2 hidden layers? Okay. Two classes, continuous scalars, target exposure fraction, target leverage, optional layer, routing logic, KX. You can take profit tuning parameters. Can we add inputs, outputs mid training? Yes, but safely if we version schemas in our reserved slots. Add a schema evolution section, reserve input slots plus feature maps for present versus missing. Prefer adding new continuous parameters before adding new discrete actions. The dimensions truly must change. Treat as a new model version. Load overlap and with new weights. Small. Choice: do you prefer target exposure fraction, using the fraction of free collateral? Fraction of total wallet grants. Oh, okay. Prefer adding new continuous parameters before adding new discrete actions. If dimensions truly must change, treat as a new model version. I think a fraction of free collateral. Fraction of the fraction of free collateral. Yeah, keep. Okay. Think I'm ready. Alright, well, thanks for watching. I'll do another video now. And when we start doing this, I'll put on a playlist that we're gonna kind of build it with me over time. I'll just kind of record everything that I do, unedited, of course, so you kind of see the whole journey unedited as I just vlog it all up. Okay, I don't really like to edit my videos because I don't like editing. I rather spend the time on programming, and yeah. All right, thanks for watching.